Yes, class. Good evening. So in the last class, we had started with reflection. Laws of reflection we have already covered, and I think I've given you this as an assignment as well. In assignment, you will find the same thing. Laws of reflection as well as the formation of images. Somebody has left. Okay, ma'am, Munna has net. Now, laws of reflection were angle of incidence was equal to angle of reflection. All the three rays, incident, reflected, and the normal, that lied in the same plane exactly. Concave mirror and convex mirror has been introduced to you. And now we had already covered what were the terms that were related with it, all the terms that were present with respect to a mirror. We hadn't done the relation between the focus and the radius of curvature. No, that we do today. Because this diagram is incorrect technically. If you see it logically, this force has to come in the middle. But because this is inaccurate without compass and scale, this has been drawn. So that's why I've written it like this only. Formation of image, sign convention we had seen. Formation of images we had seen. See, formation of images will come. Separately it will come. For all these, all these. Any of these can come. We hadn't done the relation. Let's do that first. Relation between the focal length and the radius of curvature. So relation, this also comes in your short derivations, 2 markers or 3 markers. Mainly in 2 markers this comes. Relation between F and R. Focus and the radius of curvature. Fine. So relation between the focus and the radius of curvature. Let's take a concave mirror firstly. Principal axis, concave mirror. Okay, which part should I silver? Khalid, the bulged part or the inner hollow part for a concave mirror to form it a concave mirror? This side or this side?
Ma'am, for concave.
Concave, yes, concave.
It should be outside. Like
outside. This bulged part, no?
Yeah, yes.
Correct, good. So this is the bulged part that is. Remember now, what do we call this point? The intersection between the mirror and the principal axis. This point. Memona. Intersection of the mirror and the principal axis.
Focal point?
Pole. Pole.
Yeah.
Pole of. Right? Now see. A center will be present of the hollow sphere. What do we call this center, Salman? The center of the whole inner hollow sphere to which the mirror was a part of. What do we call the center? There's a name, a complete name to the center. Salman is there in the class. Shumaira, can you answer?
Ma'am, it is called the center of curvature.
Center of curvature. This is known as a center of curvature. Now, all the parallel rays meet at a point. All the parallel rays will meet at this point. Sana, what do we call this point? Where all the parallel rays ultimately meet each other after getting reflected from the mirror. Sana. Focus, perfect. This point is known as the focus. So what will happen? Let's say rays are coming. It will strike the mirror and this will pass through the focus. Now, how will it pass through the focus whenever we are focusing? See, if I join this I join this. This is the path of the ray. Let's say this is A, this is B, and because we are doing a derivation, that's why we are naming all these. Make this angle something alpha. Let's say this angle is alpha. Fine. This length between the focus and pole. Sneha, what is this length known as? Between the focus and the pole, this length. Yes, Neha, focus and pole. This length, we have a name for this. Focal length. It will be focal length of the focus. Focal length, yes, right, Sneha. Salman, are you there in the class? Salman Nasmi.
Yes, ma'am. I just came back.
Okay. You had it in between. So this is known as the focal length. Okay, Salman, just tell me one thing. What is this separation known as between the center of curvature and the pole?
Which one, ma'am?
Center of curvature is this center of the hollow sphere, and this is the edge of the sphere mirror, that is the pole. This whole complete length, this is known as what?
Not sure.
See, if this was the hollow sphere, this is the center of curvature. What will you call this for a sphere?
Perimeter.
No, diameter is complete only from the center to the edge. That is known as
Radius.
radius. So that becomes radius of curvature. Remember?
Yeah, yes, ma'am.
Okay, so that is the radius of curvature. So we are trying to derive a relation between the focus and the radius of curvature. Radius of curvature. Now see, this will be incident on it. This is the angle of incidence and this is the angle of reflection that is occurring. Now we'll start with the derivation. So this is a concave mirror that we have taken. Concave mirror. You can do the same derivation with the help of a convex mirror. Everything remains the same, just ray diagram will be different. Now see, according to laws of reflection, angle of reflection will be equal to angle of refraction. Laws of reflection will say angle of reflection is equal to angle of refraction. Now see, if you see this mathematically, this ray AB, this is actually parallel to this pole. Let's say pole is P. So PC, both these rays are parallel. So this CB acts as a transverse. So what type of angles are these? Angle I and alpha. These are alternate angles. So it means they will be equal. So angle alpha will be equal to angle I. Alpha will be equal to angle I because of alternate angle. And since angle of incidence is equal to angle of reflection, alpha will be equal to angle of reflection also. Now see, in this triangle back, if this angle and this angle, both these angles are equal, then what type of triangle is formed? Can anyone name this triangle? This angle becomes equal. Then CFV becomes what type of triangle? Two angles are equal in which triangle?
Isosceles.
Isosceles. Yes, isosceles triangles. So it means CF will equal to PF. Both these lengths, FB and CF, these will become equal because angle of this angle alpha and R are equal. So CF will be equal to FB because this is now forming your isosceles triangle. Now what will happen? See, for a mirror of small aperture, whenever you have a mirror of small aperture, you're at this point FB and this point FP. Both these are actually equal. because the aperture of mirror is not so huge. This is done for the drawing, for the understanding part. This FP and this FP, both are actually equal in nature, almost equal. Approximation you can take. So it means if CF is equal to FB, it will be equal to FP only. Now you have done the derivation, just see. So for small aperture, what will happen? Your FB will be equal to that pole focal length as well. So you can say directly, therefore CF is also equal to FP. CF was what? CF was your, now CF plus FP is forming your complete radius of curvature. Radius of curvature is what? Alpha is the random angle that I've taken. Alpha has not been mentioned. See, the angle, this is the normal that is drawn to the mirror for the following or the formation of laws of reflection that I've extended, and that angle that it is making with the principal axis, that I have named it randomly as alpha. It is no such angle and it has no definition. This is just, we have done construction part in order to obtain the relation between focal length and radius of curvature. Now see, CP is radius of curvature. This is formed by FC plus focal length. Do you see this? This is formed by focal length. So your radius of curvature is actually the sum of CF plus FP. That becomes twice of the focal length. One of it is focal length. So radius of curvature is twice of focal length. Focal length is half of radius of curvature. So whenever you draw the ray diagrams, be careful to mention alpha is equal to R. That I can explain. See, because that is not random. Angle alpha was chosen randomly, but how it is equal, that is done. See, angle of incidence is equal to angle of reflection because of laws of reflection. And AB is parallel to this principal axis. This is the principal axis, CB. And now these dotted lines, which are the normal for this mirror, are acting as a transverse. So if two parallel lines are there and a transverse is intersecting them, then this angle and this angle, both these angles become equal alternate angles. You must have studied in your 8-9 standard. So since they are equal, I is equal to alpha and I is already equal to R. So it means alpha will become equal to R. So you get isosceles triangle. Got it? From here, you people can note down as well. Did you understand this part? Both your questions, alpha and alpha
Ma'am,
equal
could
to.
you do the derivation again?
Yes, I'm scrolling it down. Are you asking something from it?
Yes.
This part? If you have to note it down, I'll scroll it. Just let others draw the above part. Yes, yes, I'm showing it back. So in reflection, you have mirror formula. This mirror formula you have already done in your earlier classes, but you didn't have the derivation, I think. So now derivation will be there, and questions from mirror formula also come. Last year, this no question came from this because it got deleted only. So there wasn't any use of any question. Now see, let's derive the mirror formula. For a concave mirror, we'll be deriving. So in your exam, you'll be having the liberty to draw it by any mirror. So prefer it for the concave only. If it is specifically mentioned for concave, then everything remains the same, just the ray diagram. And ray diagrams for both the mirrors we have studied. But it's a liberty to you. Given, draw a ray diagram, derive the mirror formula. Maximum times it is asked, state the mirror formula is the same formula applicable to both convex and concave. So yes, both the formula that we derive right now, it will be applicable to all concave and convex mirrors, whether the image is formed is real or virtual. Now see this again, the terms that we have already discussed now. This is P. This is the center of curvature. This is the focus, F. Object I've taken, I've kept it beyond C because beyond C I've kept because this is a generalized derivation, AB. Now the rays will pass first. It will go parallel to the principal axis. Let's say this point is some M because these points will now be needed. Because it's not a simple ray diagram, we are using this ray diagram. Then you have focus. It will pass through the focus. So all parallel rays pass through the focus. Please do not write it simultaneously. After the class, whenever I write down a portion, I give you sufficient time to note it down. So that time only you can copy it. Now what will happen? One ray has gone through this. Then according to laws of reflection also, if the ray of light is hit at the pole, then it follows the laws of reflection and exactly at the same angle, this moves. So here angle of incidence is equal to angle of reflection. That also you have to keep in mind. Last ray, that will be passing through the center of curvature. So this will pass through the center of curvature and it will retrace itself. So center of curvature will be here. When you draw with compass and scale, you will get the exact points because focus has to be at the center of the radius curvature because it is dividing the radius of curvature into two parts. So this is your curvature. It will retrace itself. Now main thing, all the rays we have drawn, we are obtaining an image at this point. This becomes B dash. This is A dash. Real and inverted image. This we have already done and discussed. Now let's just write certain terms. See, this is the focal length, and now we'll be using the sign convention also. Because concave mirror is there, an image formation is there, images are formed, object is kept, object distance will be there, image distance will be there, focal length will be there. So sign conventions, we'll use it. So this is the focal length and it will be minus F because why? Incident rays direction is this and you measure from the pole. So from the pole, this is the pole. If you move from the pole, this is against the light. Or even just remember, no, anything that is kept in front of the mirror, that is taken as negative only. So focal length is on the left hand side of the mirror. So that will be negative. Because you are moving in this direction, light goes in this direction. Remember the sign conventions. Now, this distance from B dash to P, this becomes your image distance minus V. And this distance from where the object is kept with the pole. This is minus U, that is the object distance. Fine. Minus U is object distance. Minus F is focal length. And minus V is image distance. I think it's better in the exam if you write it in this way. B dash P is equal to minus C, which is the image distance. That will elaborate your answer. Now see this triangle, A, B, C, this triangle. And see this triangle, A dash, B dash, C. Both are what? Having a common side. Both are having the vertically opposite angles, which will be equal. So we can say both the triangles are congruent. They are similar triangles, ABC and A dash B dash C. Both these triangles are similar triangles. Still, let me write this. So triangle A dash B dash C is similar to triangle ABC. That was the name. So it means this side A dash B dash by AB. A dash. This is all your mathematics from your lower classes. So if you are having doubts in similarities of triangle and how do we solve this, refer to your books of class 10th and class 9th. That there it is given clearly. So if you are having issues, so you can easily refer to your books. PDF is also available. PDF is also available on the internet. You can refer once if you're having difficulty. So this side will be congruent to which side? These two sides. So CB dash by BC, B dash C by BC, and with now see, we have to name these sides. CB dash, BC. What are all these? C. This is your CB dash. So it is formed by which? This is formed by what? This is your radius of, yes, one thing I forgot to mention. This whole will be radius of curvature as well, no? From the center to this. This is minus R. Please add this as well. Minus R will be radius of curvature. So this B dash C will be what? Radius of curvature minus this B dash P. That is the image distance. From this whole, see carefully class, because many rays are passing, so it can become confusing. Clearly note down the points. CP is there. This is the radius of curvature. B dash P is the image distance. So if I subtract the image distance from the radius of curvature, I'll get this part, B dash C, which is left. So C, B dash C, what I'll write this CB dash. I'll write this as CP minus B dash P, which I can write CP was what? Radius of curvature minus B dash P was image. Radius of curvature minus image distance. That will give me this part left, C dash B dash. Now let's see the denominator, BC. This is your C, this is your B. BC. So see, B dash it will become. No, BC is this point, A, B. No, see, it will be reverse. Object I have written in reverse. This is the object. No, A dash is coming here. This is A. Now it's correct. A dash. B, B dash. Now it's the inverted image. Please make a correction whenever you write it. By mistake, I had drawn it inverted, B dash. Now see, what now we have to find? We have to find this BC. See, if this complete BP, which is what? Object distance. This BP is the object distance. If you subtract the radius of curvature, you will get BC. See carefully, guys. Whenever you're not able to understand, stop me, I'll repeat it. BP is the complete object distance. This is the object, this is the pole. Object distance. If I delete this part, subtract this CP, which is the radius of curvature, I'll get this part BC. So now see. So BC will be equal to what? BP minus CP, which is complete object distance minus what? The radius of curvature. Sign conventions we are putting it. So what we'll get? We'll get minus R plus V divided by minus U plus R over here. Fine. Now see, one more thing. These two triangles are similar. if you notice this triangle, A dash, B dash, and P. Notice this triangle, and notice this triangle ABP. They are also similar. No, they have the common side, and these angles are also equal. So by SA similarity, these triangles will also be equal. Look, ABP and A dash B dash P. Side is common, angles are equal, angle of incidence and angle of reflection according to laws of reflection. So this big triangle ABP and A dash B dash P will also be similar. So triangle A dash B dash P will be similar to triangle ABP because angle A dash P B dash is equal to angle APB. And you can put that this is because of SA similarity, the triangles are congruent. Now, once you have this, you can again write A dash B dash by AB. A dash B dash by AB is equal to what? B dash P by BP. Now see what is B dash P. This is easier. Now you don't have to delete anything. B dash P we have already seen. B dash is there, P is there. This is complete image distance. And what is BP? BP is complete object distance minus U. B dash P is minus V. BP is minus U. Now we didn't have to subtract or add because it was directly given. So this is what? Minus, this was minus V, right? And this was minus U. Minus sign will get cancelled. V by U. So A dash B dash by AB is equal to this. And A dash B dash by AB is also equal to this. This is 1, this is 2. So both we can equate 1 and 2. Just equate both these equations. Now you'll have the mirror formula. Minus R plus V by minus U plus R. This is equal to V by U. Cross multiply, minus UR plus UV is equal to minus UV plus VR. So UV can be taken together. So VR plus UR is equal to 2UV. Now if you divide both the sides by this 2UV or no UVR, if you divide both the sides, because we have to get our mirror formula. So if you divide both the sides by UVR, see what you will obtain. VR plus UR plus 2UV is there. Sorry, not plus, equal to. Equal to 2UV is there. Divided by UVR, divided by UVR, divided by UVR. What is left? V gets cancelled, RR gets cancelled. U gets cancelled, RR gets cancelled. UV gets cancelled. Here 1 by U is left. From here 1 by V is left. From here 2 by R is left. See, focal length was what? R by 2. We have derived now focal length is R by 2. So 2 by R will be what? 1 by F. If you reciprocate this, it will become reciprocal. So you obtain the mirror formula, that is 1 by F is equal to 1 by U plus 1 by V. This is the mirror formula that you obtain. Got it? This is the mirror formula that you will obtain. 1 by focal length is equal to 1 by object distance plus 1 by image distance. Clear or not? Yes, class? Got it?
Unclear.
Yes, teacher.
Okay. So this is not such a long derivation. It's not a very long derivation since the terms were confusing though, because A, B, C, D, all these were included. That's why it took time. Otherwise, in the exam, this won't take time. Once you have done it by yourself, it won't take so much time. Note it down at whichever step you're not able to understand, because it can be confusing about A, B, C, D, and many rays are passing. Let me know. I'll explain you how the rays have also been drawn. Just let me know. First, write it down.
Ma'am, can you scroll up a bit? Okay, then, ma'am.
In order to get the mirror formula, see, if you divide by UVR, then only VR gets cancelled, UR can be cancelled, and UV can be cancelled. This is the only common term that will give you a final mirror formula. Mirror formula is there, that is done experimentally. To derive that mirror formula, we are using and following all these steps. So if your aim is different, you have to reach to your aim. So UVR is the only term that will be common in all these terms. Otherwise, if you just write UV, R will remain. If you just write VR, U will remain likewise. See, if you see this part, this A dash B dash by AB is equal to B dash P by BP. This part, this, I hope you've understood, because of similar triangles, as a similarity, common side, common angle, we are having this there. The triangles are similar and you get this. So directly I'm writing it down. I'm not repeating or drawing the array diagram again. This is for linear magnification. When we'll do the optical instruments, you will have angular magnification as well. Linear magnification. So if A, B, P, and what was the other triangle? Triangle A dash P, B dash. A dash B dash from here by AB, this was equal to what? PA by BP, BP by B dash, B dash, B dash P by BP. See, A dash B dash is what? If you look at this figure, use the same figure. Right now also you can leave it, but in the exam, if only linear magnification is asked, you have to draw the diagram. A dash B dash, this is what? This is the height of the image, and it is downwards below the principal axis. So this will be negative. You get this? This is the height. A dash B dash is height of image. And what is AB? AB is the height of object. And since this is above the principal axis, we'll write it as positive. So plus, let's say H1, and let's say this is minus H2. Sign convention we are using. Then B dash P, we already know this is the image minus V, and BP, we already know this is the image object distance minus U. Now see, one line, in one line your answer will come. A dash B dash was what? Height of image minus H2. AB was height of object. Instead of writing it as 2 and 1, no, I'll write it as I or O. Otherwise you can, so that it will become easier when you remember it. So this is height of image by height of object. Like this you can write. B dash P was minus V and this was minus U. See, minus sign gets cancelled. This minus sign remains here. Magnification is equal to height of image by height of object, which is equal to minus V by U. For mirror, this is the formula that we get. Now, in both these formula that we are getting, be it your mirror formula, 1 by U plus 1 by V, be it your magnification minus V by U, or magnification is HI by H naught, or both these equal, you have to apply the sign convention. Sign conventions you have to, because this is generalized formula that we have taken, and we have derived this formula for only that specific case when the concave mirror was placed that. So if a different case is given to you, this we have derived. This is a generalized formula. Now, if an object distance is given to you as 5 centimeter, object will always be in front of the mirror in the opposite direction of incident ray. In front of the mirror means you have to write this as minus 5. So you will write it as 1 by minus 5. Apply the sign conventions wherever needed. Whenever you don't have to apply the sign conventions, I'll specifically mention you. When we'll do optical instruments, certain calculations are there, certain formulas are there where you do not write the sign convention. Here you have to include. If focal length is negative, write it as 1 by minus whatever it is written. If it is positive, write it in that way. Now, what is meant by linear magnification? This was the derivation and this was the formula. See, from this only you can write down the definition of linear magnification. Definition is what? Ratio of height of image to that of height of objects. So a ratio of height of image to that of height of object is called linear magnification. So this ratio is known as magnification. See, sometimes in the mirror, you get enlarged image. The image is magnified. That is known as magnification. But whenever it comes to define it, define magnification can be asked to you and write the expression for magnification for a concave mirror. You have to show all these steps along with the diagram. If in continuation you're writing, then no need to draw the diagram. Also, one more thing, this is known as transverse magnification as well. Transverse magnification. This is also known as transverse magnification, and this is denoted by small n. This is denoted by small n. And you have to apply the new Cartesian sign conventions. One more thing, class. In this, I'll add one more thing. See, in your exams, if directly you do not have V and H, so you can use your mirror formula to get whatever is the missing quantity. Find whatever is the missing quantity, you have to find it. For example, let's say magnification is minus V by U. You have F, you have U. You can put U, but how will you use F? So you can put it in the mirror formula and get the value of V and get M. If height of image and object are directly given, directly use it. Otherwise, you can equate it. Apart from this, in order to save your time, if it just comes in your numerical, then see how can you do. 1 by U plus 1 by V is equal to 1 by F. From here, if I do one thing, if I divide both the terms by U, both terms by U, divide both terms by U. See, I'll get 1 by, no, not divide, I have to multiply. If I'll divide, if I multiply both the terms. See, in your exam, you need not show this. This is too much to derive. In the derivation, till that step only before the definitions I have written, that is enough. But this is for your ease of calculation, if only it comes in the numerical. So this is it. If you multiply, you will get 1 by U by V is equal to U by F. Fine. Got it? 1 by U by V is equal to 1 U by F. We have just multiplied U with all these terms. Now, shift this term there and bring this term over here. So you get minus U by V is equal to 1 minus U by F. Just interchange the term. This term U by F has come to the left and U by V has gone to the right. Now see, if you take the LCM, you get, here you get F minus U by F. This is equal to what? This is equal to what? See, F minus U by F. Got it? This is equal to what? F minus U by F. This is equal to minus U by V. And minus U by V is there. If you reciprocate it, you will get V by U, minus V by U. That becomes F by F minus U. So you have one more formula for magnification. F by F minus U. This is nothing new. In the exam, no need to write it. If F and U are given, directly use this in the numerical. Otherwise, if it is asked to derivation won't be asked, lekin still, just in case. Otherwise, use normal mirror formula to get V and put it here. If you get it for V and F, so magnification will be minus V by U, F minus V by F. This is what you will get it for V and F. So accordingly, see, if F and V are given, use this formula directly, F minus V by F, that will give you magnification. Or substitute it using the mirror formula, get the value of U, put it here. This is nothing new, I have just interchanged the terms. Now, one important conclusion that you have to remember, this is not much important, this is your basic logic thing you can apply. What you have to remember is, if the magnitude of magnification is more than 1, for example, it is minus 6. What is the magnitude? 6. So that is the magnification. The image is magnified over here. Image is magnified. If opposite to this happens, see, remember, we are considering the magnitude. Otherwise, you will say minus 5 is less than 1. So do not consider that. -5 is written, consider the magnitude, because here minus and plus depict the sign conventions. They do not depict the size. If this is less than 1, then image is diminished, very small. So by magnification, you can predict whatever is the nature of the image. And if it is equal to 1 somehow, then image is same size of that of object, same sized as that of object. One more thing, if m is positive, for example +5, +4, +0.1, +3, like this, if it is positive, it means image is virtual and erect. If your m is negative, because directly see, no, unless and until image will be above the principal axis, then only you'll get the virtual and erect image for that. And above the principal axis, sign convention is positive. Below the principal axis, it is negative. So image will be real and inverted. So class, in the exam, you can get directly a question. Values will be given, image distance will be given, object distance will be given, and it will ask, tell whether the image is virtual, erect, or whatever is the nature of image and size of image. So in size, you have to mention above 3 points. In the nature of image, you have to mention below 3 points. And that can be calculated just by the magnification. For example, your magnification is -4.3. Fine, your magnification comes out to be -4.3. It is unitless, so it will be -4.3. So 4.3 is greater than 1. That will show image is magnified, and minus sign will show image is real and inverted. So that becomes magnified, real, and inverted. For example, you are getting plus 0.3. 0.3 is less than 1. So image is diminished and plus sign show virtual and erect. So this shows the size of image and this shows the nature of image. So by magnification, you can get the whole information. And this is in your question, maximum times this is asked in the parts. For example, some data will be given to you. A part will ask you what is the focal length. Second part will ask you calculate the magnification. Third part will ask what is the nature and size of the image. So all this thing will be done by this only. Understood or not?
Yes, ma'am.
Yeah? Others? Apart from Sumaira? Khalid, Memuna? Okay. So note it down. Wherever you're not able to understand, just let me know. Linear magnification. So questions are asked on linear magnification. Define magnification, write expressions for it. Directly questions can be asked. Question and everything that we'll do in the next class, but theory part for reflection is over. We'll do the numericals in the next class. Just write done in the chat column when you have completed it. Then we'll begin with the test of EM waves.
Ma'am, by the way, is it mod of M or just M?
Mod of M for the size of image, and just M for the sign of image is dealt separately for the nature of image. So just take the magnitude, because you put modulus to take the magnitude. If you have to check whether the image is of same size, diminished or magnified, so that time you have to take the modulus, like -3. So just take 3. 3 will be greater than 1, less than 1, or equal to 1. That will determine whether it is magnified, diminished, or same size. Plus minus deal it separately to check whether virtual, erect, and real and inverted. So if it's -3, so just consider minus. Minus will give you real and inverted, like this. Yes, others have also completed. Just keep on writing done in the chat column. Khalid, Sneha, Samaira. Who is left? Khalid, Sneha, Samaira. Sana and Salman, just let me know when you've done. Okay. Sana, you've also completed? Sana? Yes, yes. Just let me know till where. This part? Yes, yes. Just try it yourself. This you people can try. See, put now initially what we did for the first part when we got f by f minus u, we had put the value of u, that v, that was unknown. If you do the same thing and try to find out which is the left one, no, for image you'll get the opposite formula. My f minus v by f. For u and f you get f by f minus u. For v and f you get f minus v by f. So yes, that is opposite. So f minus v by f. Okay, class. Now, EM wave stress, as I've already informed you 1 week back. Now you don't have any test in the upcoming weeks because we are dealing with ray optics only. You have to identify the waves in the first, second part. In the third questions, amplitude, frequency have been given, wavelength, and the electric fields expression. This question we have already done. Question 4 also, you have to compare it with the main equation, see whatever things are unknown. Similar question for 5th. See whatever things are given, write down the equation for electric field. All these questions we have done in the class. And last question is relative permeability. Speed and relative permeability is given. You have to find out relative permittivity. So epsilon is unknown, mu is given, and speed is given. So I'll do all these questions and submit your PDF on the group. So combine the last week's papers and this paper. I'll give you the scores by Friday. Memuna, you can leave. I've got your answer sheet. Thank you, teacher. Samira, also you can go. Okay.